All right, class. We have our experiment set up here. And what I'm going to have to do in this particular case is I'm going to have to call off the numbers if you guys can't see them. And so this is the measuring point. So these numbers you'll need to input into the lab. What we're trying to do is to confirm the law of reflection and the law of refraction. Okay, here we go. So right now we're coming in at 90. And 90 is just going to be our zero or our reference. We're going through this glass plate here, and then we're going to go to 90 on the other side. So this should be pretty much aligned. We're trying to go through a point by which we're going to circle. That's our pivot point. So let's go ahead and do this. We're going to go ahead and move to 10 degrees away from 90. That's going to end up being 80. So if we look at our beam coming off here and align it a little bit, it's close to 80, so it's 80 for the reflection. So that means 90 minus 80 is going to give us 10. And then if we look up here, and I'm just going to come around, and if you look at the top right here, you'll see that we are around 83 and a half. So right in here, this is 83 and a half. And that's our refracted beam. So basically, we have our refracted beam coming through. So let's just do the same thing, and let's move on over here to 70. And we should be able to tell if we're at 70 right here. And so that's 20 degrees away from 90. And we have our other beam coming off right here. Let's see if we can pretty much align up right there. It looks like it's about 69 and a half. So if you guys look real close, it's about 69 and a half. It's close enough to 70. And then our refracted beam is going to be, let's see what we have here. It is 77 and a half. So I don't know if you guys can see that, but it's 77 and a half. So let's go ahead and go to 60. Let's make sure that our beam is on 60. Okay. And let's look at this beam right here. Okay, and this beam is coming out around 60 as well. So that's good on the reflection. The reflection beam is at 60. And you guys do the necessary calculations. Now, this time you don't see the beam in the glass, the reflected beam. It's because I have a little epoxy in here. But you do see the reflected beam, or refracted beam, not reflected, but refracted beam on the edge of the glass. So now we're going to need to go back to the pivot point and use those 2 points to form a straight line, and then we'll see what we have. We are right around 72 degrees for our refracted beam. Okay? And then we're going to keep going. 50. We're at 50 right here. Okay? And let's see what our reflected beam is saying. It's about 50 as well. Then our refracted beam, which is right here, it's going up to that point. Right over there. It's about 65. Okay? Let's go ahead and go to 40. Okay, this is our reflected beam right here, my pivot point. And we're about at 40 for our reflected beam. And now, if you look, we have our refracted beam, and it's hitting the glass right here. And that's at about 62. It looks good at about 62. Okay, so let's continue right on. Let's go to 30. And at 30, we have a reflected or reflected beam. Reflected beam is coming over to 30 as well. And our refracted beam is 50, 58.5. Okay. And now our last one. This is 20 degrees away from 90, so that's 70 degrees. So let's look at our refracted beam, reflected beam. It's a little iffy, but it's close to 20. It's kind of off a little bit here, but it's close to 20. If we go from the pivot point down the beam, it's about 18. No, about 22. So it's about, let me put this up here so you guys can see what I'm seeing. It's about 22. I mean, we can argue that it's 20, okay? And then we have our refracted beam right here, and it's just going through, and that is 50, looks like it's about 57.5. Okay, so that's where we'll stop with this particular experiment. So make sure you put your data in the experiment appropriately. Hopefully you were following along. I wasn't really giving you a lot of time to do the appropriate calculations, but if you need to, just go back and look at it. And remember that you're going to use 90 as your reference point, and then whenever we go over to an angle of 80, you subtract 80 from 90, you have 10 degrees. Okay? You have to do that for each one of them. 90 is the reference point, and then our other angle is going to be subtracted from that to give you our angular difference or our angular displacement.